And welcome everybody to another exciting discussion about geometry. Today we're going to be talking about area. As you probably already know, area is the total number of square units inside an object. So this first example, what you're going to notice, which is really nice, is that these are perfect square units. So if we were to just count, you would see that we have inside of this object 8 square units. Now, we're going to make sure that we label them as square units, or we could also call them units squared. I'm going to be using these both interchangeably. Both are correct answers, but what we're really concerned with is making sure that we put the proper labels. So let's say that we're talking inches, it'd be square inches, or if we're talking feet, it'd be square feet or feet squared. However you want to write it is fine. So let's make sure that we put the proper labels if they ask us for them. What else we're going to need to know are some formulas for area. Okay, so what I would suggest is if you want to write these down, pause the video, write them down, and resume when you're ready. I'm going to discuss each of these with you right now. So as you can see, a triangle has an area of 1/2 times the base times the height. What you notice, hopefully, is that our base and height are labeled, but what I'm really concerned with is that you see that our height is always going to be perpendicular to our base. That's going to be the truth for all of these shapes. Our height is always perpendicular to the base. Now, why might that be useful? Well, in a lot of the situations, seeing as this is coordinate geometry, we're going to hopefully look for the easiest side to count, and it's always the easiest when they are perfectly vertical or perfectly horizontal. So if we happen to see a triangle, we could use any of these side lengths as our base, but we want to probably choose the horizontal one because that's going to automatically make our height vertical, which is another easy thing to count. Okay, and you're going to see that in a problem or two coming up. The next shape is a square. The area for a square is the side length squared. That's why they're called squares. Makes sense. So we find the length of one side and square it, we'll get the area. Parallelogram. Parallelograms cover rhombus and rectangle as well as a strictly parallelogram. And you'll notice area is base times height. Again, our base and our height are perpendicular. And our last one is trapezoid. A little bit of a different formula here. Excuse me. Area for a trapezoid is 1/2 base 1 plus base 2 times height. Notice how you have two bases in a trapezoid, and you have a height which again is perpendicular to both bases. So we would add these bases, divide by 2, and then multiply by our height. If you're interested in where any of these formulas come from, you can either see me in class, which we actually did these in class, or if you're interested enough, I can even possibly put up a video about where these formulas are coming from, if I get enough requests for it. Alright, let's take a look at some examples. Our first example says that we want to find the area of parallelogram QRST with the following coordinates. Now, if you didn't know what this symbol meant, that's fine, because when you draw out your shape, you should hopefully recognize that it matches with the parallelogram from the chart that we just looked at. So, we need to know the formula for the area of a parallelogram, and that's really easy. It's just base times height. The second thing you're going to notice is that our base here is a nice easy thing to count. It's perfectly horizontal. So for our base, we have the length of 1, 2, 3, 4, 5. I also am happy about choosing that particular base because I know that my height has to be perpendicular to it, which is easy enough to count. I have a height of 2. So when I substitute these values in, I'm going to have 5 times 2, so my area would be 10 square units. So there's going to be 3 more examples. If you would like to try them on your own, all you have to do is pause the video before I start explaining the solution, do the problem, and then resume when you are ready to check how you did. Okay, so this next problem says to find the area of triangle XYZ with x at -2, 0, y at -2, 5, and z at 4, 2. I'm going to connect all of my points. Now, I had mentioned that we could use any of these sides to be our base on this triangle, but we want to think of the easiest one to count, which is also going to help us find the height because of the fact that all of these grids are perpendicular intersections. So I'm going to use this side right here. It has a length of 5, so that's my base. From the highest point perpendicular to my base, I have a height of 1, 2, 3, 4, 5, 6. We know that this is a triangle. We can see it. It says it right in the problem. So our formula is 1/2 times base times height. When we substitute in our base of 5 and our height of 6, we notice that we're going to have 1/2 of 30, and half of 30 is 15. And we're talking about square units. Two more examples to go. Again, if you want to try these out, go for it. Okay, this one says find the area of square LMNO with L at 2, 0. So here's L. M at -1, -1. N at -2, +2. And O at 1, 3. So here's our square. Now, we can't just count the sides on this square. They're not perfect vertical or horizontal, so we can't just count the units. We can use the distance formula. Or if you so choose using the counting principle, that's fine too. I'm going to use the distance formula. I'm going to use LM as one of my sides. So it's the square root of y2, which is -1, minus y1, which is 0, squared, plus x2, which is -1, minus x1, which is 2, all under the radical. Alright, so that's the square root of -1 squared plus -3 squared. That's going to give us 1 plus 9, which is square root of 10. Now, you could type in square root of 10 into a calculator and get a decimal and approximate it. You can do that. Not saying not to. However, you're going to get a more accurate result by just squaring this number. Because remember, we're talking about a square. So what we're looking to do for area is one side length squared. And we just found this as root 10. So if I substitute in root 10 for s and then square it, I should notice that my root and my square cancel each other out, and I'm left with an area of 10 units squared. Okay, so if you get a radical, that's not a bad thing in this situation because you're just going to end up with a whole number anyways. That's the nice thing about squares. You usually get a nice whole number like that. Okay, and our last example is a trapezoid. So, if you'd like to try this one on your own, go for it. Let's see what this one looks like. A is at 1, 1. B is at 1, 7. That's way up here. C is at 3, 6. And D is at 3, 2. If I connect all of these points, we can see our trapezoid. Now, with a trapezoid, the bases are the sides that are parallel to each other. So the sides that are parallel would be A, B, and C, D. So one of my bases is going to be 1, 2, 3, 4, 5, 6 units long. My other base is 1, 2, 3, 4 units long. And our height, again, remember, is perpendicular to the bases. So we have here a height of 2. Now, checking back at your formulas, area of a trapezoid is 1/2 base 1 plus base 2 times height. I'm going to now substitute in. We have 6 for base 1, 4 for base 2, and 2 for our height. That's going to be 1/2 of 10 times 2. 1/2 of 10 is 5 times 2. And lastly, 5 times 2 gives us 10 units squared. So that's it for area. If you are given a shape without a coordinate plane or coordinates, you just really easily look at the side lengths that they give you and the heights and everything else. They'd have to give you something to work with. If they give you coordinates, plot it out. Use the distance formula when necessary. If not, just count. A lot of them are easy enough to count. Any questions you might have, leave on the website for me or bring them into class. Till next time, guys.